We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
Can AI help us build resilience into the energy grid, even in the face of unforeseen challenges? Today's episode is hosted by Dr. Francesco Leofante, a research affiliate for the Centre for Explainable AI at Imperial. His research focuses on safety and explainable AI. His guest today is Mary Cleary, Vice President at Neara, leading on communications and public policy, currently focusing on the energy sector. She has extensive experience in bringing AI products to the market. In this episode, they discuss challenges in modelling AI for a critical infrastructure, major applications for grid resilience, repairing models for policy and regulators, and new opportunities in AI.
Thank you very much for joining us today on this episode. My name is Francesco Leofante, and I am an AI researcher here in the Department of Computing. I do research in AI safety and AI explainability. Today, we have this very interesting topic, AI for critical infrastructure systems. But before we start with the technical bits, Mary, would you like to introduce yourself?
Yes, I'd love to. And Francesco, it's such a pleasure to meet you. Thank you very much for having me on today. So my name is Mary Cleary. I lead comms and public policy at Neara, and I've spent the bulk of my career bringing complex AI products to market in a variety of different industries. And in my current role here at Neara has given me the most compelling and interesting problem set to date, which is looking at energy. So before all that, I was also a history major turned banker. So for me, my role is a very fascinating combination of really all the disciplines that I love, since our technology is really starting to play an outsized role in public safety, public policy, what that means for financial markets, and how all of the chips kind of fall therein.
That sounds very interesting. You mentioned a lot of interesting stuff. So if you don't mind, I would like to start from, one of the first things you said, complex AI products, right? And now in particular, in the context of energy, what kind of AI are we really talking about here in the context of critical infrastructure systems and power grids in particular?
Yeah, so at Neara, we call ourselves a physics-enabled digital twin. And I'll just give you a bit of context, and then I'll explain how the AI fits into that. So what I mean by that is we're not just a simple visualization tool. So we're actually looking at the relationship of every asset in the network, every pole, every wire, to its physical surroundings. And not just to the assets themselves, but surrounding vegetation and roads and bridges and man-made structures and things of that nature. And also not just in a steady state context, right? So we're looking at this in the context of a flash flood or an ice storm or a heat wave and such. And the way those simulations work is dependent on building a really robust 3D digital model of the network. And the role that AI and machine learning plays, that the foundational role that it plays in that, is the classification of multiple sets of input data and the initial model build itself. So we're a data agnostic platform, which means that we're looking at lots of different types of disparate data sources. So in many cases, that often looks like some combination of LiDAR, GIS, different types of imagery, pole specifications, things like that. But the important thing to note is that each of those sources brings something really important, some really tangible context to that model that makes it rich and something that utilities can rely on for analysis, right? So LiDAR, for example, really good at measuring distances between two spaces. So distance between two wires or can tell a tree from a distribution pole, things like that. Imagery is somewhat obvious, but it does things that LiDAR can't, where, you might see an image rot on the top of a wooden pole that wouldn't be captured in a LiDAR scan. So anyway, lots of different disparate data sources that need to be stitched together, first classified and then stitched together in a way that really completes a holistic picture. And that is the primary foundational way in which our technology is using AI to model critical infrastructure.
I see. That sounds very interesting. So, in summary, you have a very fancy digital twin that takes, right? Am I right? So you have a lot of data coming from different sources, and then I'm curious. So you mentioned AI is used to classify data, but are you also using AI to reason about data, or is the reasoning done with other techniques, more sort of traditionally, if you will?
Yeah, so this is actually something that makes us quite unique is the reasoning itself, the analysis. So you've got the model built, now it's time to run an analysis and see, for example, which poles are going to fail in a hurricane. That is based on physics verified calculations. So these are the same physics calculations that generations of engineers have grown up on and built their careers around. So it is it's highly verifiable, auditable, and it's not AI sort of black boxing telling you which poles you need to replace.
Right, right. That's that's very reassuring, and that's also very interesting. And now I was wondering, given this amazing technology that you have, and all the great things that AI can help us do, I was wondering if you could tell us a bit more about the specific use case when it comes to grids. What kind of models do you build? How do you use these models? And again, what is the role of AI in this whole, very interesting problem?
Yeah, so maybe one bit of context I'll share also is I just talked a bit about the foundational application of AI in our platform, but very much like digital transformation, there's actually a pretty broad spectrum in terms of the adoption curve where utilities are in AI adoption, to begin with, but also AI maturity. And so some utilities are in a place where they're actually using our technology to build their own agents on top of existing workflows, in which case AI plays more of a role in the reasoning. But that's the utilities who are really on the cutting edge, who've had a lot of domain experience with this already so far. But coming back to your initial question about the major applications for grid resilience and such, is utilities use our platform to simulate scenarios that they need to prepare for. So that could be anything from I'm building a new transmission line, like the north-south one in the UK. I know I need it, but where do I put it? How do I get it approved faster? So, which do I underground parts of it? Which terrain is going to be the best? How do I actually get this thing approved faster? It could be something like looking at coastal infrastructure and figuring out how do I flood-proof that? So how do I protect transmission towers from erosion? Or it could just be what infrastructure do I actually need to service a 3 to 5x, multiple of load growth.
Mm-hmm. That's very interesting. It also sounds like some of the research I do, I work on counterfactual explanations. With counterfactual explanations for AI models, you can generate what-if scenarios. So you basically modify the inputs to your AI model and you see how the model behaves, right? So I guess counterfactual reasoning is a very interesting sort of, I don't want to call it an application, but you can actually do sophisticated counterfactual reasoning with your tools. That's very interesting. Something that we will talk a bit more about explainability later. But before we get there, I would like to ask you a couple of questions around sort of the way you collect your data, right? Because especially when we talk about data-driven AI, machine learning-based applications of AI, we all know we need data, right? And I'm aware that in the energy sector, the infrastructure is not necessarily up to date. Sometimes it's a challenge, right? Because you want to collect data, say from areas with very few sensors, if any, right? So you have this problem that you need data to build good models, but in some cases you really don't have the data to begin with, right? So how do you deal with this kind of challenges?
Yeah, so what you're saying resonates a ton. This is definitely a challenge. But I think it's one of those challenges that becomes a circular reference very easily if you don't just start someplace. There's a lot of anxiety around utilities that think, oh, well, I don't have enough data, or I have the wrong type of data, or my data is old, or where do I start kind of thing. And what we find is that even if that's true, even if you don't have the right data or it's in bad shape, sometimes you need to start doing some sort of analysis just to figure out where you are, what kinds of data you do need. So, for example, one of the things that we see very often is the quality of GIS is not great. So, maybe a utility only has GIS, and maybe they know it's not great, but they just kind of want to see where they're starting from. So we pull it into the model, and we might see that 1 in 20 poles is actually not where the initial map says it was, and there are also a lot of assets that are not documented at all. So that's scary, right? Like that doesn't necessarily make for a good day for the person who sees that analysis, right? But at the same time, better you find that out sooner than later, or in a bad scenario, and it brings your attention to, well, where do I need data? Where are the blind spots in my network?
That's very interesting, actually, because a lot of the conversations I've heard about AI in energy, they're probably a bit pessimistic in a sense. There's a lot of focus on, oh, but we don't have enough data, and the infrastructure cannot keep up with us. But now what you're suggesting is, if you will, a more pragmatic approach where there's always going to be some data. Let's start from that, and let's see what we can get out of what we already have. That's a very good point. Very interesting. Now, again, on data, you said you have many different sources, right? Many different sources of data. And then I was wondering, when it comes to effectively training these ML models to process this, I'm assuming, vast amount of data that you have, there's a lot of concern nowadays around the cost of training AI models, right? Especially when it comes to large language models, these big, generative AI models that are used for many interesting applications. I was curious, are you using anything like that in your applications? And if not, what kind of AI are you using? What kind of ML are you using? Is it an expensive one? Is it expensive to train this kind of AI models for your applications? So I know it's kind of many questions, together. So.
Yeah. So the specific types of models and the cost is maybe a little bit out of my swim lane, but now I'm a bit curious. What I can say about the cost is I think we think about it more as opportunity costs than as a hard number. Of course, there are costs with any process or doing things a certain way. But I think data itself is not cheap, let alone there's the training cost, which you're alluding to, and then there's the cost of data acquisition and processing and such, which is also not casual very often. But I think where we come back to and the way a lot of utilities think about it is opportunity cost. So what's the cost of not doing things differently? And, we've seen a dynamic that we've seen in the US is that fines and violations for things in the realm of safety, outages, et cetera, have increased by over 800% in the last 5-year period over the prior 5-year period. And that's a pretty staggering opportunity cost.
Yeah. No, that's very true. It's also interesting. So you mentioned you operate mostly in the US, or is it also in other parts, like in the UK, for instance?
Yeah, so we're actually global. So we grew up in Australia, but now we work with utilities on 4 continents.
Right. That's very interesting. So, dealing with the regulatory landscape in all these different countries must be very interesting. I mean, I have a couple of questions about that, but I will talk about. I guess I will ask you about policy and regulations a bit later. Before we get there. Still a bit on the challenges that you face when deploying your technology, right? So. As I mentioned at the beginning, I do research in AI safety, AI explainability, okay? So, in a nutshell, what this means is that I develop solutions, algorithms, to effectively make sure that when we deploy an AI model, we can check that the AI model does exactly what it is supposed to do, right? So it behaves, if you will. And the second one is explainability. So whenever the AI model produces an output, even if the output is 100% correct and it's you're very happy with the result, there are many applications, energy being one, where sort of you need more than just accuracy, right? So you need accountability, you need transparency, you need explainability, right? So because these are systems that eventually will be used by operators, right? So you need ways to make sure that the outputs of your models are sort of human friendly, if you like. So, do you have this kind of challenges, and if so, how do you deal with them?
It's a great question, and a point that really resonates deeply. Something we see a lot, and again, something I think that makes our technology quite unique in this regard. So I'll give you an example. So I was mentioning earlier the AI adoption curve across utilities. So some of the most sophisticated ones that we've seen are, they might have homegrown systems where they have hundreds of risk models that they're operating and have been operating for many years now, and it's worked pretty well. Except the challenge is that now, and also, by the way, they're so complicated that they are breaking the limits of not just their internal data warehouses, but also, let alone spreadsheet systems like Excel. But now the challenge is regulators want access to that. They want to understand that. They want to audit the numbers and say, wait a minute, how did you get here? Or why is this the input? Are you saying that every pole in the network needs to, be able to withstand 400 mile an hour winds? Maybe that's a bit much. Do you really need all this money? And so what we're seeing is that they're actually coming to us to say, can you help us untangle this and make it legible to a third party that doesn't have, 15 years of institutional knowledge at my utility? So that's something we see quite a bit.
Okay, and would you be able to tell us a bit more about the actual process? So once they come with a why or a why not question, how can you actually help them?
Yeah, so it comes back to the physics verified formulas that influence every calculation. So all the inputs are exposable to a regulator. So it doesn't necessarily require a PhD in physics per se, but anyone who has trained on physics could sort of pick apart and distill any calculation in the platform down to its component parts and see what the inputs are. So if you have, to come back to that example, if you have stipulated that every pole needs to withstand 400 mile an hour winds, that might be excessive. And you might be able to easily adjust it to say, well, what about 100 mile an hour winds? And does every pole in the network need to have that? Or is it just subsections? So, maybe a northern face on a hill kind of thing where that type of weather is more common. So it's really about stripping down the output down to its component parts and those inputs, and making sure that regulators and utilities can constructively agree on, do we think that is reasonable? Do we think that is the appropriate way to hedge risk, not just at any cost, but at the right cost for the communities that they're serving?
That's actually very interesting, because it kind of reminded me of. I also I work on another topic which is called contestable AI, right? So we have safe AI, we have explainable AI, and now we also want to have contestable AI, right? So this is an AI that can sort of that can be contested, right? So you mentioned regulators, for instance. They might come to you with questions, right? And I wonder, what happens if it ever happens, but what happens if they disagree with the outputs of an AI model, of your model, for instance, or in general? Is there a way to deal with kind of, processes? I guess my question is it something that happens at policy level, say, or lawyers, or is there something technical, right? Do you have an algorithmic way to deal with what is known as redress, where, you have a contestation that is successful, right? And now you want to effectively repair your AI, your model, to fix it. Do you have something like that in your system?
Yeah, so maybe I'll share a bit about how we're thinking about that, and you can tell me if it's on target or not. But yeah, so an example of what that could look like is, again, setting those sort of threshold for what's appropriate. So another example could be clearance, for example. So in California, just given the wildfire risk and the emphasis on vegetation right now, there are regulatory requirements for certain types of vegetation clearance, and then some utilities will actually take it upon themselves to say, the regulators are asking for this level of clearance. Well, I'm going to go above and beyond and be super careful, and I'm going to impose even tighter clearance metrics. And they might change that depending on where we are in the season as well. If there are Santa Ana winds, then they might actually make the clearance requirement even tighter, just to be extra careful. And so what that means in terms of using the model and applying the technology to that is that it's actually a pretty easy swap in for the, whatever the rule is, and it ripples through all the calculations and resets the risk priorities. So our position with AI and just rules in general is we never want to be the ones who are authoring that. We don't want to be, that's not up to us. That's on utilities and the standards bodies at play. So they're in the driver's seat. Yeah, entirely. And then they tell the technology what to do, and our technology acts as sort of like an enforcement layer for flagging and stratifying things that color outside their lines.
Yeah, I think that makes a lot of sense, right? Because I feel today when you hear people talking about AI taking over, and sort of killing us all, I think there is a misconception here. AI is a tool, right? And it is a tool for us to use, right? So I think it's up to us to design it in a way and to deploy AI solutions in a way that is safe, right? Which basically means you cannot have AI, sort of an end-to-end system, AI-based system that, takes inputs in and actually acts on the grid, for instance, right? Of course, this would be crazy, right? You need some human oversight, right? So that's how I would do it. So yeah, it's very interesting, and I was wondering, in terms of sort of before moving to the sort of the way forward and policy and regulations, I still have a couple of questions around some other potential barriers to the adoption of your technology. We've talked about explainability and safety. I was wondering whether privacy is also a concern in your applications, whether, cybersecurity, because I'm assuming cybersecurity, for instance, should be very, a hot topic or a great concern for energy critical infrastructure systems. So is that something you ever had to deal with, or is it something that you sort of account for in your platform?
It's something we account for. I wouldn't say it's something that we directly address, but it's something that we account for in that we have all of the ISO security certifications, things like that. Utilities also, understandably to that end, will ask us to handle data, in very sensitive, careful manners, and we are fortunate to have the flexibility in the architecture to entertain really whatever kind of setup works for them. But yeah, that's a hot one and very important to us as well as our customers.
Yeah, nice. And again, now, as I said, sort of a bit on the interaction with regulators, because this is something that I had the opportunity to sort of, engage with a bit here in the UK. So talking with regulatory bodies here. Everybody's excited about AI. Everybody's aware of the promises of AI. But then, where do we start, right? So you suggested a very pragmatic approach that is, give us your data. Let's see what we can take out of it, right? And maybe it will be, maybe we'll find something interesting and, sort of baby steps towards a greater goal. But then you also said that you've interacted with regulators, or anyway, utilities. Actually, it wasn't regulators, it was utilities who have rather sophisticated models, right? Where you said they already have their own kind of systems, right? But then sort of, what are the challenges there in terms of regulations, right? I don't know if the US, well, I'm assuming the US will have a different approach to, say, Europe, for instance. I mean, that's always been the case when it comes to regulations. Sort of, what are the challenges that you face there?
So I would say that the biggest
big question.
Yeah. I think that the biggest challenge is actually the lack of direction and guidance. I think there is an awful lot of talk about what utilities can't and shouldn't do with AI, as there should be, right? Like that's, not to take anything away from that discussion. But there is also a startlingly sparse dialogue around what they can and should do around AI. And certainly here in the U.S. and I think to a large extent in other regions as well, in other countries, there's this, I have to go ask mom and dad for permission for everything I do, every dollar I spend, etc. And without that overt blessing and guidance, and sort of specific guidance of like, here's what you should do and encouragement, really, I don't think that very much is going to happen. So,
right.
There's, I don't think Ofgem has any specific, Ofgem I'd say is maybe more prescriptive and ahead of a lot of the public utility commissions at the state level in the US in terms of encouraging digital transformation and things like that. But I don't believe I've seen anything that explicitly says, here's how you should use AI, here's how we, AI is good for X, Y, and Z, not good for, A, B, and C kind of thing. And certainly there's very little dialogue about even the digital piece in the US. So I think that's a big challenge.
It is, right? So I know that Ofgem have released, like last week maybe, a document on, ethical use of AI in the energy sector. So things are happening, right? But I also know, for instance, earlier this year, I organized an event on using AI and explainable AI for critical infrastructure systems, energy and critical infrastructure systems. And I was talking to operators in the US. And that's the big challenge, and that's the answer that you get from all of them, right? Yes, AI, very nice. We would like to use it. We just don't know sort of how, we don't know where to stop in a way, right? I mean, there's a technical challenge to it, but there's also the policy regulatory challenge there, right? Because everybody would like to do something with it, but then it must be, your job must be very interesting, dealing with all these different, frameworks. But then again, when it comes to, I suppose, I don't know, when it comes to the things that governments maybe or regulators should do, right? Like if you want to express, I don't know, a personal opinion, or if you want to, speak on behalf of your company. But what do you think the priorities should be here? Where do you think we should be looking at now if we really want to be serious about deploying AI in these applications?
Yeah, so one specific thing I think needs to change in the U.S. is, I'm not sure if there's an analog in Ofgem's world, but the shorthand for it, there's versions of it in different state jurisdictions, but the shorthand is kind of the 45-day rule. And what that means is that when utilities discover a risk, of course it varies to a certain extent by risk severity and such, but generally speaking, if you see a risk, you have to do something about it immediately. That's not crazy, right? Nobody wants risks. I found it and then I went out to lunch and went for a walk. Nobody. That's not what anyone wants to happen, and not what anyone's trying to do. But that enforcing that mentality also puts you in a very reactive position, where you have to address whatever risk you just found, even though the risk you might find this afternoon could be 10 times worse and require 10 times as many resources to solve, and you've just detracted from the pool of resources that you could have used to solve the risk that was way more important for something that wasn't as important or urgent, just because it was found first. And so the specific thing that needs to happen, I think, is to evolve those policies to reflect the fact that technology like this exists. And suddenly we're in a world where utilities are able to step back and observe many more risks in a given moment than they were ever previously able to. And it's just not realistic. And that also creates not a great incentive also, because if you're in a position where you know you're going to get your hand slapped or your name dragged through the mud or something bad is going to happen to you, you don't want to see the risk. So how do we use technology's availability to actually encourage more proactive behavior instead of stymieing it?
Yeah, that's a very good question. Let me know, when you find the answer. But it is true that something needs to change, and I think everybody's aware, right? So things are changing, and now we're also we're facing challenges, right? Many new challenges like extreme weather conditions, right? Things are happening now, and these are things that were not happening before, right? So, and now I wonder whether there is room for AI to help us in these kind of scenarios, right? Because I mean, there is prediction, of course, right? You can potentially sort of model these scenarios and come up with very sophisticated, refined predictions of what's going to happen, right? And then potentially act before it's too late. So has this ever occurred to you? Have you ever sort of had to deal with these kind of situations where AI was, in fact, AI saved the day?
Yes, absolutely, and 100%. I think AI's role in helping utilities prioritize effectively before something happens, I think that's really where the rubber meets the road. Something we like to talk about a lot is utilities think they have 1,000 problems, and in many cases, 1,000 is, simple shorthand. They have many more than that. So they do. Mm-hmm. They have a lot of problems, right? But they've actually got one problem that's way more consequential than all of those problems. One problem to rule them all, which is that they don't know where to start. So mm-hmm. they're forced to think about capital allocation in this like very scary, like what comes to my head is like a picture of 1,000 little red dots everywhere, right? And the challenge is that you don't know what's behind any one of those red dots. One of those red dots could be a part that needs to be replaced, and it's just a routine thing. And another one could be a transmission tower that's ready to blow across a highway in the right set of wind conditions. How do you know which one to do first? And if you're the mm-hmm. person who's in charge of allocating capital and you can't see the difference between the red dots, the consequence, you can't understand that what the likelihood of the risk is, what the consequence is, and what the intervention cost is to prevent it cleanly, that's a huge problem. So that's really mm-hmm. AI's role from where we sit is in the prioritization piece.
Right. So this is sort of you're describing applications of AI where you can really sort of rank your problems based on the risk and cost and potentially other metrics, and sort of help us, users, I suppose, pick the biggest challenge first.
Exactly.
And then, yeah, that's something where I can really see AI being very useful, right? Because at the end of the day, one of the big challenges is that you just have too many things happening at the same time, right? Or, you have too much data, right? Or too many documents to read, or too many, challenges, right? And you need to find a way to react quickly. The interesting bit to me is that sort of when you do this, you still have this problem that sometimes sort of you cannot really trust the output of the AI model. Again, in a sort of, you cannot take the output of the AI model sort of blindly, right? You still need to look into it. But at the same time, I don't think this is necessarily a big problem as long as you have human operators, as long as you have us involved in the loop, right? So you can definitely use AI tools to, in a way, boost your productivity, if you will, right? Even if it's not, just writing emails, it's something really serious, managing the grid. But there is definitely room for these applications. And sort of maybe one last question. Sort of, can we use AI? Now, I don't want to sound like, sort of one of these AI doomers, right? Or anyway, people who tend to attribute, who tend to think of AI as something more than what it actually is, right? Because I've been working on AI like for 10 years now, so I kind of pretty know where the limits are. But do you think there is a way in which AI can actually help us, build resilience into the grid? Also even in the face of new challenges, right? Events that sort of never occurred before, right? So how can we future-proof our systems using AI in such a way that maybe we can save money and potentially more than just money?
Mm-hmm. Yeah, it's an excellent question. So, and the short answer is yes. I do think there's a ton of potential for AI to do that. And how that takes shape is, I think, if you look at weather, for example, right, where a lot of places, including parts of the UK and the US, are still doing weather modeling based off of historical patterns, which is, not insane again, but also needs to change, right? Because we're seeing weather patterns that are not consistent with what we've seen in the past. So just you can't expect the same thing to keep happening again. You also can't expect your infrastructure to keep responding the same way to escalating challenges, right? So where AI can be really helpful there is by assisting a simulation that shows how the infrastructure will respond in situations that are independent of what you've seen in the past. Again, with that physics verification, looking at finite element analysis, for example, in the context of really high winds or flash floods, and looking at the exact stress points on poles and other assets when they will fail.
Yeah, that's very interesting. Actually, I was wondering, now that you're mentioning, these different applications or scenarios, I was wondering, how do you make sure that your model is kind of, doesn't diverge too much from, what you have, right, at the moment, from reality, if you will, right? Because you need to make sure to sort of update your model every now and then, right? Something new happens, you definitely want to you want to leverage this new data, new information, right, to make your model even better, right? So I'm assuming you will have some sort of, continuous loop where you keep integrating, right?
Yeah, absolutely. So feedback loops are really important to your point, to keep the model up to date and refreshed. So there are a variety of different ways that we do that. One of the most straightforward ones is probably field services integrations. So when when a risk is detected and some sort of maintenance needs to occur and a team gets sent into the field to actually perform said maintenance, we have integrations with a lot of upstream systems where we'll take into account the fact that the repair was completed and that maybe changed some characteristic of the asset. For example, maybe a cross arm was added, or maybe the direction of a wire was rerouted across the street or something of that nature. That change will get reflected into the model.
That's very interesting. It sounds like a very sophisticated system.
I like
But
to
it
think
has
so.
to be, right?
Yeah.
It has to be if you want to use it. Yeah, if you want to use it, and if you want to, if you want to produce good results, it has to be sophisticated. There's no way around it.
Exactly.
Okay, so I think I've kind of asked you all the questions that I wanted to. So, is there anything that you think I sort of any burning question, any very important thing that I should have covered and I didn't, when it comes to using AI in these applications in energy?
I think we covered quite a bit of ground, but I also am curious, Francesca, for your perspective on what you think the biggest opportunities in AI are.
Yeah, so that's something I've been working on for the last year. It's kind of a recent thing for me, in fact. I started to interact with some colleagues here at Imperial, energy people, right? And in fact, it was with the Energy Futures lab here at Imperial. And then I started to think about all the different ways in which AI can be used, right? What I am mostly interested in is AI for decision making, right? So that's kind of the AI that is not doing forecasting, for instance. It's really the AI that says, okay, now you should really, sort of pull that plug, or sort of, this is, of course, as I said, you always want to have human oversight. But I think the applications of AI where, you suggest, so you give actionable sort of feedback, right? And you give suggestions on what can be done to the physical system. I think these are very interesting applications, but there's a lot going on, right? Also, when you think about sort of customer-facing applications, which we didn't really talk about, right? Because it was mostly like, AI and utilities. But there's also a lot to benefit from our perspective, the users, right? So when you think about sort of, personalized sort of, plans, right? So switch on your washing machine now because it's going to be cheaper, right? There's a whole range of applications where AI could be deployed, and I think the potential of AI here is that really you have this very nice tool. AI to sort of reason about very complex scenarios that go way beyond, the Excel file and what a human brain could possibly, pick up, on within a reasonable time. So we have all these different applications. I think the main sort of challenge for me, and again, I don't have a product, right? So I'm a researcher. I focus mostly on algorithmic development. The main challenge is to find, this one nice application where you can really show that years of research on, say, safe AI, explainable AI can effectively be deployed to change things, and when I say change things, it's kind of whatever, right? It could be increase user trust or increase efficiency, accuracy. There are many ways, right, in which we could measure sort of the performance of AI. But yeah, I think there's actually there are a lot of people within the research community that are focusing on these kind of problems, AI in energy. There's of course a lot of work that has been done already. And going forward, I would like to see a bit more of this, how do we make sure that we have solutions that can be explained, right? Again, I'm biased here. I do explainable AI, so that's kind of the obvious answer for me. But this is kind of where I think there is a lot of space, like a lot of opportunities, right? Because at the end of the day, you have AI, so you have you have AI here. You have technical people, utilities, regulators, sort of us, the common people, right? So you have all these different parties that have to sort of in a way, that sort of all want to use AI with different goals. And how do we make sure that sort of we make sort of everybody happy, right? So this is it's there's going to be, I think, a lot of interesting problems in this space.
Yeah, absolutely. And I think, I love the work that you're doing with explainable AI specifically, because that's such an important part of the story. And I think that's the key to making AI a really mainstream part of the energy transition, is the explainability part, because the stuff is not inexpensive, right? So if we're justifying the level of spend that needs to go into the grid, we better be able to show that it's working and that people's money is going to the right places and such. And I think AI can play a really, really powerful role in that.
Yes. So let's all do explainable AI for energy.
Yes.
No, it's. I think it's a very interesting problem to be working on. So hopefully there's going to be, as I said, more happening within the near future. So I guess that's it from my side. Thank you very much for joining us today. I think I've learned a lot about the different ways in which AI can be used to effectively build resilience into power grids. Thank you very much, Mary.
Thank you so much, Francesco. Pleasure speaking with you.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content. Until next time, stay curious.